Let's start the topic Sonatype Nexus. Before we actually start about the details of the Sonatype Nexus, let's have a preview of the content which we are going to cover in this session. We will be starting with understanding the concept of packaging and package management. Then we'll be covering repository management and repository manager concepts, followed by the Sonatype Nexus, how to install it and its user interface. Then we'll be covering configuration of Sonatype Nexus, how to configure roles and users Sonatypes. Then we'll be using Maven to create the repositories of different categories like hosted, proxy and group repositories. Then we'll be covering how to upload and download an artifact using Maven from Sonatype Nexus. Then we'll be using Docker repository to set up Sonatype Nexus and how we can push or pull the images using Sonatype Nexus repository. Then the concept of npm will be used with the Sonatype Nexus. Then yum repositories, there are certain other concepts like how to upgrade Sonatype Nexus, how to take backup and restore, cleanup policies, how to use webhooks, and how to use it the .NET package repositories with NuGet. So this is the preview of the table of contents of Sonatype Nexus. So before we actually go in the detail of the Sonatype Nexus, let's start with the background of the packaging concepts. What is a package? If you are asked a general definition of package, how do you define a package? A package is an object or a set of objects that are bundled together. It can be of any object or a group of objects that are bundled to form a package. In terms of software, how do you define a software package? A software package is an archive file or a set of archive files that contains a computer program or a piece of software. The software can be an application software or the set of libraries or a development code that are bundled together and eventually are instructed to make them work and produce certain results. That is a formal definition of a package. The package can be a source program or a source code, or it can be an executable file. Conceptually, you can think of a package as being similar to the different folders on your computer. You might keep similar type of files in one folder. For example, you have a set of images. So you can contain all those images in one particular folder. And you have another set of files like scripts or application code that are stored together in another set of files or a folder that is also make a kind of package. Same way in terms of programming languages, say Java. A Java program composed of hundreds or thousands of individual files, classes, and it makes sense to keep things organized by placing related classes and interfaces into packages. Packages can be categorized in two types. One is the built-in packages and others are user-defined packages. What are built-in packages? Built-in packages are the packages which are pre-compiled for a computer program like operating system installers, setup files, database packages like SQL, Oracle, etc. So the packages which are provided as a computer pre-compiled applications are known as built-in packages. The user-defined packages are the packages which are also known as build your own package. A package whose specification and body you write yourself. You decide what programs and data are publicly available and how those programs should be called. Packages or applications created by users like binary files, jar files, war files, or any other kind of executable files are an example of user-defined packages. Next comes the concept of metadata. What is a package metadata? What do you mean by metadata? Metadata in general means data about data. What does it mean? That means a package also contains further information like which might include the package description, the package version, licensing details, etc. etc. So these kind of details are being described by package metadata. That means that contains the information about the package data, that is known as package metadata. Next comes the concept of package dependencies. What do you mean by package dependency? A package dependency means the prerequisites and other related packages that needs to be installed beforehand. For example, to install packages like Oracle or Maven to compile Java application, they are dependent upon the other packages like Java, JDK, JRE, etc. etc. So before you start using Maven or any other Oracle packages, you have to have Java installed and configured on your machine. So these Java packages or the JDK and JRE packages are known as package dependencies. That means the main package is dependent upon any third party package. So these dependent packages have to be pre-installed before installing your main packages. That is known as package dependencies. Next comes the package formats. What are the various kind of package formats? A package format is a type of archive containing computer programs and additional metadata needed by package managers. Some common package formats are DB for Debian-like packages like Ubuntu, RPM for Red Hat Enterprise Linux and Fedora-like operating systems. MSI is a kind of package format for Windows operating system, and many other distributions are based upon those kind of package formats. Next comes the concept of package manager, or also known as package management system. What is a package manager? As the name suggests, it manages the packages. That means it is a collection of software tools that automate the process of installing, upgrading, configuring, and or removing the computer programs for a computer's operating system in a consistent manner is known as a package manager. Package manager are designed to eliminate the need for manual installation and updates. Typical functions of package management system or package managers are first, working with file archivers to extract package archives. For example, you have an archive of a package in any format, say TZZ or zip format and any other kind of archive format. So to extract those archiving packages into a normal package is the one of the function of package manager. The second one is ensuring the integrity and authenticity of the package by verifying their digital certificates and checksums. For example, when you install an operating system or a package, it asks you for the license agreement. And once you accept the agreement, then only it allows you to install the package. That means it maintains the authenticity and integrity of that particular package. So this is one of the function of the package manager. The third one is looking up, downloading, installing or updating existing software from the software repository. That means the maintenance of the package, whether it is to be download or upload, to install it, to upgrade the existing package or downgrade it, and any kind of management related to the package is one of the functions of the package manager. The fourth one is grouping of the packages by function to reduce the user confusion. As we have discussed earlier, a similar type of files grouped together to make a folder. Same way, grouping of the packages based upon the type of the files. For example, all the libraries related files, say DLL or dynamic link libraries files are stored under a folder known as libraries. All the source code related packages or the files are stored in another folder. The executables are stored in another format, say target file. So this grouping of the packages based upon the functioning to reduce the confusion or the overhead is another function of the package manager. And the last one, the fifth one, is managing dependencies to ensure that a package is installed with all packages it requires to fulfill dependency requirements. For example, say makefiles. If you are building your code using the makefile, then makefile supports not only building the executables, but it also responsible for installing all dependent files on the library. So to manage the dependencies is another function of the package management. These are the few important features of the package manager. Next comes the concept of package repositories. What is a repository? You might have used the repositories like Git repository, or you can say SVN repository, or GitHub, Bitbucket. These are the repositories which are used to store your source code, right? The same way, the repositories which are used to manage your binaries, like your executables or your artifacts, we use certain kind of repositories or known as package repository, just like a Sona type repository or artifactory, etc. So the package repositories are mainly deals with managing the artifacts or the binary code are known as package repositories. Is it clear? Next, as a whole, how do we find the package management system? We have covered all these components separately. So if we combine together, like if we combine packages, package dependencies, metadata, repository, package manager, and user system, if we combine all these components, that makes a full-fledged package management system and how they are related. If you look at the diagram here, the packages are connected with its package dependencies and metadata. That means when you install packages, they make sure, that means the package manager makes sure its dependent packages should also be installed, and the metadata related to the packages is also installed. The repository, that means the location where you store your package, that is connected to the package manager. So package manager first pull the code or push the code to the repository, and that repository contains the other component of the packages like metadata and package dependencies, etc. And user system is connected to the package manager. So user or the end user is connected to the package manager. It is the package manager responsibility how to manage your packages, including its metadata and its dependent packages. So this is the overall diagram or the configuration of package management.